Good morning to one and all. Today's topic is related to these ground improvement techniques. In the previous class, we discussed different images. That means we elaborately discussed different images about these ground improvement techniques. But today's class, we have to go for a detailed explanation and different concepts in this reinforced earth. Normally, this reinforced earth or mechanically stabilized earth is a soil constructed with artificial reinforcement. That means reinforced earth or mechanically stabilized earth. Both are similarly synonyms in our civil engineering terminology. First of all, reinforced earth means some quantity of reinforcement is induced in the earth structure to improve its stability. Okay, it is called as a reinforced earth. Second term, we are having mechanically stabilized earth. Here also we are having a stabilization with the help of mechanical. That means artificially we are using some quantity of steel and these densification techniques in the form of mechanical equipments utilization. Likely that is called as a mechanical stabilization of earth. The soil is constructed by using this artificial reinforcement. Normal reinforcement means with the help of availability of some quantities of fibers in the form of roots and other things which are naturally available in the soil. Likely in olden days the trees are having some root structure, so that the root structure is having some reinforcement phenomena, so that there will be less amount of erosion whenever there is a roots in the structure. Likely if in nowadays there may be some less quantities of trees due to this urbanization technique, so that there may be huge amount of erosion we are observing. In some of the cases the trees are not utilized in the construction activities because of these optimum site distance and mean site distance problems. We are not utilizing these plants for stabilization purposes. We need to go for some artificial reinforcing agents. Likely here reinforcing earth is an artificial stabilizing agents. It can be used in different principles. First of all, we are having these retaining walls. Normally, retaining walls are used for the purpose of slope stabilization. That means whenever a structure is having some slope, due to its slope, automatically there may be some dropping or some erosional activities like takes place whenever there is a rainy season. So that due to those activities we have to go for some quantities of artificial densification techniques like retaining walls. Next one is the bridge abutments. That means bridge abutments we have to observe in national highways. These bridge abutments have to be solidified by using these reinforcing techniques. Why? Because those bridges have to bear huge amount of these natural loads coming from this movement of vehicles and a drop down of different agencies. Likely next one we are having these dams. Dam is a structure which is have to bear huge amount of hydrostatic pressures. In the dams also we are having a different classifications: earth dams, concrete dams, and other slope stabilization dams. All those are. In those also we are using this reinforcing earth phenomena to give more life to the structure. Next one, sea walls. Whenever there is a movement of these ships and boats along these coastal areas, so that there may be force developed on the surrounding areas of these sea walls. And the next one is the tidal waves. Moreover, along 365 days and 24 hours of a day, the tidal waves are simply getting some quantities of force to these seashore structures, so that these sea walls also we have to go for this reinforcing phenomena to control these erosion causes. Next one are dikes. These are the dikes also one of the example of these sea walls. Normally sea wall means along the area, but in case of dikes means some of the ships are placed near to the harbors to that means loading purpose and unloading purpose. Some ships are maintaining near to the harbors. In those areas we have to use these reinforcing earth phenomena. Why? Because the ship means that is having huge amount of weight. Due to that weight also the water may be penetrated into the soil structure. To control those kind of penetrations, simply we will go for this kind of reinforcing earth to arrest the water penetration into the structure. Why? Because if the water penetrated into the earth areas, automatically the seas having some salt content. Due to this salt content penetration into the structure, there may be some physical properties and structural properties may be weakened. To control those intrusion of those salt content into the structure, definitely in the dikes and sea walls we have to go for this reinforcing earth phenomena. This is the example. Likely the many of the structures have to be constructed with the help of these arrangements. We are having this arrangement of structure. We have to observe what are the different types of these earth retaining walls. It is the best example, so we have to observe it is a retaining wall or facing. Next one, reinforced earth is a material formed by combining earth and reinforcement. Normally earth means a soil mass. According to the soil mass we have to form different agents. If it is that means we have to go for different quantities of agents whenever we are constructing a structure. Here also we are having reinforcement. That means normally only soil means there is no stability. To give stability to the structure, simply we are giving some quantity of reinforcement to the structure. That is a soil reinforcement. By combining those two kinds of earthwork and reinforcing work, it is formed as a reinforcing earth. Normally we are having a different synonyms for the earth according to its types. Ground may be different nature. Normally earth covers all types of grounds in the nature. Throughout the world we are having different classifications. Throughout the world we are having different classifications of the soil. Likely we have to observe in our Asian countries, one side of the Asia is completely under this sand areas. That means Dubai countries and other countries we are having totally soil in the form of sand. But in case of our India and China and Bangladesh, we are having normal soils with different chemicals. That means red soils, black soils and granular soils likely. So that their physical properties and their chemical properties should be vary according to their appearance and sizes of the particles, so that there may be some variance from land to land, including the both granular soils. The earth exhibits some slight cohesions. That means according to its particle size there may be some variation in the structure, so that those structural properties we have to observe, and after that we need to go for different densification methods like reinforcing and dewatering techniques. Next thing is it can be include all particle sizes. That means the earth structure having different particles. On the top of the earth we are having maximum a fine grain particles. Why? Because the top layers are more overly attached to these erosional properties, so that top layer we are having some more fine particles. After that we are having a simply increment of these soil particle sizes, likely sand, silt, clay, and likely we are in opposite direction. First of all, we are having clay, silt, sand, and granular soils likely. After that granular soils, below the earth surface, we have to form these stones and boulders likely. It can be formed that prefabricated elements. Normally reinforcing earth, we have to go for these prefabricated elements. Why? Because those elements we don't have to be constructed in the site. Why? Because if we are constructing those elements in the site, we have to face a lot of time waste. That means in the site means there may be need of huge amount of workers and machines and other tools, so that there is no chance to construct in the structure. That means some of the chances we have to go for construction, but it will takes a lot of time and disturbance to the public in the form of traffic jams and other sound pollution and environmental pollution. So these kind of structures we are using in industries for construction purpose. The word reinforcement is used to define all linear components. That means reinforcement is a linear. Why? Because it is in only one direction. The total structure is located in one direction. But in case of slabs and other things, they are in two directions. So both x and y direction are having some radius and lengths. But in case of this reinforcement, it is only one-sided size. So that we have to, one side means simply we have to take a bar. The bar orientation is simply in one direction, so that we are called as a linear mass. The earth mass is constituents with compact shapes close to the sphere or cube. As a result, we will call them as a grains or particles. Normally earth or mass constituents are with different compact shapes according to their observance. If it is a cube or sphere, as a result we will call it as grains or particles. Normally if the earth particles are having different shapes, if the particle shape is in a square, automatically we will call it as a cube. Or particle shape is in a circle, we will call it as a grain or any sphere. Likely according to the particle shape, we will call it is in a different names. If it is like a grain, the total particles we will call it as a granular soils. That means the total soil is not having bond, those are having different natures like grains, so that we are called as a granular soil. Next one is reinforcing members are simply elongated elements with one dimension clearly greater than the others. That means reinforcing elements, normally bar we have to take. Normally a length of the bar is 40 feet, diameter will be varies. Some of the bars having 8 mm, 10 mm, 12, 16, 20, 24, 28, likely the diameter will be varies, but in case of length is similar 40 feet. So that we have to go for different particle sizes and these shapes and lengths of these bars. Earth alone or least granular earth according to its definition used in soil mechanics. So that the soil mechanics is the subject is entirely deals with the properties of the earthen materials. So that at least we have to know some quantities of properties, minimum properties of the earth, like what is the shapes, what is the textures, what is the minimum properties, we have to understand all those things. Earth is made up of non-cohesive particles. That means non-cohesive means there may be some non-bonding particles are there. When horizontal beds of flexure, that means flexure means some quantities of tension forces are applying in different horizontal layers of the earth. Why? Because due to its simply movement, we are having these tensional forces or flexural force. But in case of rectilinear reinforcement are introduced into the earth. Rectilinear means simply a kind of reinforcement which is having different shapes. Those reinforcement we will call as a rectilinear reinforcement. Introduced into the earth, whole mass exhibits some cohesion. Cohesion means simply one onto another, likely shear we are facing. The cohesion is entirely opposite to this shear force. It is a body of reinforced earth. This cohesion of reinforced earth is arises from friction of grains of earth against these reinforcing members. That means cohesion force of reinforced earth arises from friction of grains. Normally, cohesion force will be formed due to this action of particle bonding. If the particle bonding is very high, automatically cohesion force is less. The particle bonding is very low, this cohesion force also increases. Why? Because the friction between the particle to particle is high, automatically this bonds also very high. Friction is low, strength is also low. There is a transformation of forces by friction between the grains and these reinforcements, introducing the cohesion and whole mass. Next one, we have to go for some quantities of assumptions while we are designing a structure. Likely here we are knowing this reinforcement earth, so that we need to have some quantity of data on this reinforcement earth. It assumes that the grain reinforcement friction sliding, therefore means the assumes the grain reinforcement friction without sliding. Without sliding means normally there may be no cohesion forces applying on the structures. Why? Because simply the structure is having reinforcement, therefore the reinforcement members must be arranged that in a condition always met. That means along horizontal direction we are having some quantities of reinforcement, and along vertical directions also we need to have this reinforcement. Then only we are having some bond with another material and the soil mass. Otherwise the forces will be transferred in only one direction. In the another direction there is no transfer of forces, so that simply a cohesion force or compressive force will be applying on the structure. Due to these tension forces, the structure will fails. Since the reinforcement can be placed along the directions in all three axes of the trihedral. That means if it is a cube-like structure, on three directions we have to place this reinforcement. If it is a normal square-like structure, we have to face in a two directions on both L axis and longitudinal axis and lateral axis. We have to place this reinforcement. Likely, whatever the structural shape is there, according to the shape of the structure we need to place this reinforcement for equidistant distribution of these stresses. It can be easily understood that the reinforced earth body may be presents cohesion in all direction. That means due to this transformation of that means normally transformation of this steel in all directions, there may be some cohesion force should be transformed in all directions of the materials. Consequently, it is possible to build structures of reinforced earth in any desired shape. Due to its movement of stresses in all directions, we need to construct in any shape. That means any shape means whatever the shape required for the structure. In those shapes, we have to design according to its application of stresses and area of construction work. If the structure's stresses developed in the reinforcement depends upon the some of the contact actions between the earth particles. That means contact area means automatically if there is a bond between particle to particle, that bond strength we will call it as a contact area. As a result, the reinforcement is properly placed and designed. That means properly placed means along from the particular endpoint, we need to give some quantity of distance. Likely, here also we have to maintain some reinforcement details in the structure. Otherwise, due to its irregular pattern, automatically stresses also not transferred easily. Some of the places will absorb huge amount of stresses, some of the places will having less quantity of stress distribution. Due to those there may be some failure or structural span will be decreases. In short, friction is basis on the theory of reinforcing earth. That means the total friction is having some quantity of relation with this reinforcement. Why? Because In the structure we are having this mass, the total mass is one medium, and the reinforcing mass is another medium. In one medium there will be some less quantity of bond between the particles because of this homogeneity. In another structure, that means another medium of material, we are having steel having some homogeneity. Whenever we are combining this steel and the reinforcement together, automatically there may be some strength increment due to these two homogeneous particles are combined together. Next one, once the proper contact between the earth and the reinforcement is established, the problems becomes one calculating stresses in the reinforcement and the earth. That means after fixing this soil mass and reinforcement with together, then the total body will act as a single body. That means in the before case we are having two bodies. First one is earth mass, second one is this reinforcement mass. After the combination of this earth mass and reinforcement as a single unit, there may be stress distribution in only one body. That means total body will absorb the stresses from soil to steel and steel to facings and facings to the ground surface, so such that the stresses will be distributed in a easy way, and the reinforcement will be having some huge amount of load bearing capacity whenever it is fixed to this earth. Next, different types of reinforcements. In the previous classes only we have observed different types of structural alignments in areas. That means the total this reinforced earth is there, the total reinforced earth is how many types it was to be used in a different structures, what are the facing elements, what are the longitudinal bars, how those facing elements are arranged, how the stress distribution was takes place, and how it was neglected. But in case of today's class we are totally discussing different types of reinforcements and their distribution of the mass to the structures. The most type heavy foundation works can be built with reinforcement. Why? Because most type of heavy foundation works, normally heavy foundation means huge amount of load is beared by a structure. Due to its huge amount of load bearing capacity, we are going for design a structure with a huge amount of foundation. Why? Because the total foundation having a tendency to drop down into the soil, otherwise there may be fresh stresses will be more in the structure. Earth as well as the concrete, the respective weights of these two materials being quite close. That means normally concrete density is 25 for RCC, and for PCC concrete density is only 24. Likely earth also having some density. Moreoverly, these two densities are similar whenever we are going for construction, so that there will be some equi force distribution in all directions. Thus, the volume of reinforced earth structure can be similar to compare as a concrete. Why? Because the total materials are manufactured from these earthen materials. Normally, lime is also available in the earth, and silica available in the earth, and this clay is also available in the earth. By using those materials only, we are forming this cement, so that cement having some quantity of density. Likely, whenever we are using this reinforcing earth, the total reinforcing earth also having some soil mass, so that the soil mass also having some density. Moreoverly, this reinforcement density and soil mass density are similarly equal in some conditions. Why? Because here we are doing some solidification. That means solidification means simply compaction we are doing. Due to this compaction process, the density of earth also increases, so that similarly this densified earth and concrete mostly having same density and same volume. Next one, earth retaining structures we have to observe in this particular figure. We are having earth retaining structures, the total soil having some breakdown. Those breakdown structure we are constructing with the help of these retaining walls, simply facing elements. In this particular case, the facing elements are responsible to pick the materials which are loosened from the upstream areas. That means here we have to observe a total structure with a huge amount of hilly area. In those particular hilly area, there may be some movement of rocks from top level to bottom level. So that the top level to bottom level movement is takes place automatically. Along with the particles, there may be some brakes will be applied. That means breaking of strata will be applied to the hilly areas. To control those breaking of strata, we have to go for this kind of earth retaining walls, so that these walls are responsible for further decreasing the further contention of the structure. This is the slope retaining structures. Once you have to observe the thickness of the slope retaining structure. On the top part we are having a 25 feet thickness. In the bottom part we are having a 70 feet thickness. Once we have to observe, the total dotted portions are simply soil particles. The straight lines are simply these reinforcing elements. The black portion is simply a cover block. On the top face we are having a road construction. After that a simply smaller thickness of this geopolymer sheet. The larger thickness is this cover element. Here also we are having cover element on the places. First one, reinforced earth structures can be built on flat ground or on slope areas. In this particular figure, we have to observe the reinforcing earth is constructed in slopey areas and as well as straight portions. The permit structure on this French-Italian highways was built to retain a large slope. That means here we are having a 200 feet. That 200 feet is the overall depth of the structure. In this particular 200 feet also, totally we are constructed for a 95 feet of this stabilization. That means along a vertical stabilization of 95 feet we have done to control this erosion of the structures. Why? Because on the bottom there may be some variation, and on the top also we are having some variation along the slope. In those particular slope variation areas, we are going for this stabilization using these covers and reinforcement. Why? Because on the top itself we are having some slope. Suddenly the slope will be changing. At that particular areas we are constructing this reinforcing structure or slope retaining structures, so that at particular areas the bars having a tendency to pick up all those materials, and those will control the further erosion process. That means on the further there may be no erosion due to this reinforcement pigment. Okay, this is the best examples we have to observe on the in this particular diagram, and cross section also we have to observe. Next thing, platform of supporting structures in Vigna works on the French-Italian highway. That means all those we are observing are the case studies. Why? Because if we have observed these case studies, we have to get some quantity of knowledge. Why? Because case studies means automatically they have to face a lot of consequences and problems while they are going to design this kind of structure, so that whenever we are studying those consequences, similarly those will be useful for us to get a more quantity of knowledge on these topics. These Vigna works on the French-Italian highway consist to reinforced earth walls. In the previously we have discussed two reinforcing earth walls, top one and bottom one. And the top quantity is directly sloping to the highway platform. The surcharge is caused by this highway is taken into account in calculating the distribution and the size of the reinforcements inside the structure. It is always possible to design a reinforced earth structure to support whatever the external forces are extended upon it. Okay, this is also another example. That means the simply in the previous case we have observed a diagram with 200 feet, but in case of here we have to observe the total height of the structure is limited to only 75 feet. On the 75 also The total 50 feet we are going for construction, and the remaining 25 feet is leaved for the slope. Why? Because the slope is variant on this 20 feet and 30 feet only, so that on those particular portions we are going for this retaining wall construction. And beams and foundation matter, these are the different examples we have to observe. That means in this particular portions also we have to use these earth retaining walls and slope stabilization techniques. First of all, the reinforced earth principle has been used in the two works of this kind. First one is the foundation of a mat to support a canal that had a pass over the section of ground containing gypsum beds wherever cavities could be accepted to form due to floating. The other is a roof over the uranium mine in Gabon. Both structures were made with wire mesh as reinforcement inside the mass of the granular soil. This is the total example they are giving. In these particular examples, mostly we have to observe two fact, that means two case studies are dealt. First one is totally related to normal reinforced earth with some foundation work, but second one is totally related to foundation work which is related to this uranium mine. Okay, in this particular first topic, the foundation was a mat foundation or raft foundation. Simply we are giving a slope stabilization to this mat foundation. Why? Because the ground containing some gypsum beds. Normally gypsum is a weak material. Whenever we are constructing a structure on these weak beds, definitely we have to go for this ground densification method. Why? Because the gypsum is very weak in nature. On the second content is totally related to this uranium mine in Gabon. Gabon is a state or a country. In this particular country, we are having this Gabon, that means uranium mine. To protect this uranium mine, we have to go for some stabilization techniques in the form of granular mass. Next one is underwater structure. What is underwater structure? How we have to protect those underwater structures? First of all, underwater structures can be built with the help of same elements. Why? Because if there is no homogeneity, automatically the structure have to fail. Using an aluminum magnesium alloy to prevent this corrosion whenever working in seawater. Normally, if there is a iron content in the sea, because sea water containing some salts, those salts will have to react with this normal steel elements and it will cause corrosion. But in case of this aluminum or magnesium alloys, alloy means a combination of three metals. Due to this combination of 2 to 3 metals, automatically there will be less quantity of formation of these small waste materials, so that we are using these aluminum magnesium alloys to prevent corrosion effects whenever we are doing these underwater constructions. Next one is the prefabricating technique have been used in the speed up of the work. Prefabrication means uh, the total materials which are useful for the construction are prefabricated, means before they are constructed in the factories, and those elements we have to use in the structure. By simply fitting work we have to get this total structure in a less span of time, including the skin elements and reinforcing strips have been assembled on the land and set into a place under water as a unit weight. That means the total n structure is dividing into n number of parts. Those n number of parts we need to unite in a single way with the help of these bolts and nuts in underwater constructions. Next one, how the construction process was takes place. First of all, sand is then poured and reinforcing strips released layer by layer by piers or harbors having been built in the France using these prefabricating techniques. First of all, we have to observe these prefabricating techniques and applies in the state of France. That means in the France they are going to construct a structure. For that particular structure, the majorly used material was sand. That sand was poured. after the pouring of sand is over, simply they are going for arrangement of reinforced bars. After a reinforced bar and the sand is over, simply they are going for another layer for construction. Likely a layer by layer, layer by layer, layer by layer, they are constructing up to a particular depth. Many other structures with varying shapes and sizes could be built. That means many other structures. In the previous case, only where you observed a structure with underground, that means below the water level, the structure is there. But in case of utilization of this system, we have to go for a different kinds of structural designs. Those structural designs will give a good quantity of result. Walls to support highways or railways in urban areas, dams, coffer dams and tunnels in case of embankments. Normally, a support highway. While we are constructing a highway, the highway having huge amount of length, thousands to 10,000 kilometers and sometimes lakhs of kilometers also there for a long highways. Along the highways, we have to face some quantity of number of these obstructions in the form of small lakes or ponds or any other intermediate structures. Whenever we are upcoming those intermediate structures, we need to have some data. That means what is the length of the intermediate structure, how length we have to construct a passage, whether it is a super passage or under passage. We have to collect those data. After collection is over, we have to go for these structures. If the line, that means if the national highway is there, on the national highway we are having some dam structure, so that this dam also we need to construct by simply this construction process like reinforcing earth and others. Next one, coffer dam. Normally coffer dams are used for the purpose of production of electricity and power. And tunnels and embankments, that means tunnels means normally tunnels are also a simply canal like structures used to carry water from mainstream to substreams, and it have been projected to tested and calculations have been developed. For each and every structure we need to have some quantity of data. The data is sufficient, then only we go for construction. Without proper data, we don't have to go for construction work. Next one, assembling of these constructions. In this particular figure, the total structure is assembling in the groundwater. That means underwater structures. The total facing element is simply injecting into the water stream by using these cranes. The total crane is lifting the facing element and simply assembling in the water. That means preliminary we have to assess what is the length of the structure and the width of the structure. For those lengths and widths, how many number of facing elements we have to, those facing elements, how many number of bolts we require, so that how much amount of workmanship required, for each worker how much amount of oxygen required. All those conditions we have to assess in the preliminary conditions. After that we have to go for this fitting process. Why? Because simply without any calculations we are going, and fitting means that will leads to faulty designs and failures of the structures. Here also we have to observe these are the facing elements. Other side of the facing element, simply we are having some notches, so that those notches simply adjust the matter into the structure. Next one, reinforced earth properties and engineering problems we have to face. First of all, the reinforced earth in civil engineers is a recent technique in this particular subject. It means the total this reinforcing earth was developed in 1950, but the usage level was very high in 2005. The first structure was built in a 19, that means the technique was implemented in 1950, and first structure was constructed in the year of 1964. Its usage as a construction principle arises from the several characteristics of indicates the place is applicable to this in future. That means the construction principle arises from several characteristics. The total structure having several characteristics. It indicates the place it applicable to fill the future. That means if we are constructing a road structure, the road structure have to be used for a long span of years so that the structure will having an application of this reinforcing earth. Next one, properties of this reinforced earth. What are the different properties we will get after this structural? First one is heavy weight, second one is unit weight, third one is the heavy weight and unit weight, second one is the strength properties, third one is the flexibility, fourth one is simplicity. All those four things we have to get whenever we are constructing these reinforcing earth structures. We will get next, further topics will be explained in the next class.